Welcome back to another long overdue update, and today I am going to be giving you an update on the Reefberry Pi, which is my DIY aquarium controller, which I started working on about a year ago or so. This is just a little project that I started working on. I had a Raspberry Pi single board computer, wanted to do something with it, and well, I'm into fish tanks, so why not try to make an aquarium controller? That was the idea anyway. So I started tinkering around with it, came up with some ideas, and it's just sort of been evolving. This is a project that I work on when I get time, and sometimes it's sat for months at a time where I haven't done anything. But recently I've gotten back into it, and I've been starting to make some progress, and just give you guys an update on where it's at. This is not going to be a how-to or tutorial or anything like that today. We can get into some of that stuff later. I know we started off doing that, but there's a lot to cover. I'm just going to warn you right now, this is going to be a long video. So sit back, get your popcorn if you're interested in this, and show you where we're at today. So I don't even remember fully everything that was in or working the last time I showed this, so I'll just show you what I have now. So as I said, this is running on a Raspberry Pi. It's a little single board computer. I'll show you that a little bit later. And I've written some software to interact with this Raspberry Pi. Everything is written in the Python programming language. And I've got some sensors connected to this. I've got some relays connected to it, and I can collect data, log that data, analyze that data. I can control the relays, which are hooked up to outlets, and I've got a lot more planned for this. So probably the last time I showed this, it looked more like this. It was just a single window. And excuse me if I cough or sniffle during this, because I'm getting over a cold. But anyway, it was a single window. And basically I had everything running, in one process, just sort of to test things out, to see, what I could get working. And it was encouraging, so I went ahead with the project. Obviously, this was not the way to go, to just run everything in one window, because everything started when I launched the application, and everything ended when I closed it. Not really ideal. I want this thing to be operating, from the minute I power on the Raspberry Pi. It should immediately, jump right into the server and start collecting data and doing everything it needs to do. Shouldn't need to run any application, and it certainly shouldn't stop working, when you end it. So what I decided to do was to split this up into several pieces. So the first piece, which is hide this, is basically the server. So the minute that the device powers on, basically the server program will kick on and start running. And this will basically just start running the program that it was set, by the user. And basically that means, it's going to connect to all of the probes that you configured it to connect to. All of the outlets are programmable, not unlike, an Apex, say, where each outlet can be assigned a different profile, whether it be, a lighting schedule, return pump, skimmer, something like that. They all have their own separate profiles, which will react a little bit differently, and we can get into that. So a server will kick off in the background, and in normal use you wouldn't see this. It'll run in the background, but for debugging purposes, I leave it up in the foreground. And then, as a user, you will come in and launch your application to launch your dashboard. And here's where you get to interact with the program to get your status updates and everything. And this also has some processes running in the background, which is basically communicating with the server. So every time the server has something to share, it broadcasts out a message, and the client application will pick up on that message and update the user interface for us to give us the latest, temperature, pH, all that stuff. And it's, been working out really well. So I've talked about, the programmability. When I first, started with this, everything was kind of just, coded to my system. Wasn't really given much thought into configuration. I just said, hey, I want to make this work for my system alone, and off I went. Well, things started to work pretty well, and I wanted to run this on another one of my tanks, which means I needed to come in here and start to update the source code. That's just a pain. You don't want to maintain two branches just for the same thing. So I went back to the drawing board and said, hey, I need to be able to program this thing on my own, on the fly, make this configurable for any fish tank I want to put this on. So I wrote a configuration utility, which I will show you. And I'm still working out some things, so I need to just stop the server momentarily while I run this. And that brings up the configuration utility, which will allow the user to come in here and change things such as the temperature scale, temperature probes. I'll show you this in a little bit. This works with DS18B20 temperature probes, and I made it configurable so I could plug basically as many of them in as I want. Excuse me. And you'll be able to configure them here, and I'll show you that in a little bit, a live demo. Outlets we'll come back to in a second. Environmental, I do have an environmental sensor integrated. It's a DHT11 or 22, and that's just a external temperature and humidity sensor. Figure that could be useful, maybe in a fish room if you want to monitor your humidity. Switches, I don't have these hooked in yet, but I will put some float switches in there so that they could be programmed to certain outlets to turn things on or off when they need to be. Analog probes. This is where we'll be able to hook up various analog sensors. The Raspberry Pi does not have any analog input pins, so I needed to use an analog to digital converter, and I've integrated in an MCP 3008 chip, which is a 10-bit analog to digital converter, and it has 8 channels on the chip. I've only wired up the first 2 channels, channel 0 and channel 1, but I have the potential to go out to 8 channels on this, which means I could hook up simultaneously 8 different sensors. I've only integrated in the pH sensor so far, but I plan to add a salinity probe very soon, maybe ORP and anything else I could find, really. Shouldn't really be much effort to get that integrated into here. They all work very similar once it gets to this point. And then feed timers. I've decided on 4 feed modes, very similar to what they have on the Apex. So it'll be 4 buttons. You can configure these timers however long you want, and we could demonstrate this. So let me just shorten that down to 60 seconds, which is 1 minute obviously for the feed timer A. PWM, that's pulse width modulation. I'm in the process of integrating this. I haven't finished that yet, but this will be used for controlling any sort of lighting fixtures or pumps that operate, say, on a 0 to 10 volt analog signal, such as like the Kessel lights. I have the Kessel A80 light on my little 5-gallon Pico tank, so I'll be using this chip that I have to control that light, so I'll be putting that in here soon. This could also be used, I also have a Refugium light, the other Kessel, the H80, which will be able to be hooked up to this. Stuff like maybe dosing pumps or wave makers, whatever. I got some boards, I think they have 16 channels on them, so I should be able to hook up wide variety of equipment, once I get that in there. Then finally, alerts. I haven't done this yet. It'll probably be one of the last things I do, but when certain things trigger alarms, I'll have it either text me a message or send me emails, whatever. So I haven't really thought that far ahead yet, but that'll be one of the things that'll be in here. And then coming back to outlets. So this is where a majority of the stuff is happening right now. And the outlets, obviously, we want to all be able to control as much stuff as we can. But the Raspberry Pi only has so many pins available to it on the GPIO. There are 40 pins on there. Not all of them are going to be available, for outlets. So I needed to decide on a fixed number that I'm going to set aside on the Raspberry Pi for controlling outlets. So right now I have 4 pins reserved. I'm going to expand that to 8 pins. There's plenty available for me right now. But I think I'm going to expand this out to 8 pins on the internal bus. Then you see I also have external bus. So the idea with this was that, I want this to be expandable. So the idea is to connect something like an Arduino over USB and allow me to basically gain access to all of the pins that are on an Arduino. And I think there's like 16 pins or something like that on there, or it could be more. And I've briefly tested this, and it seems like it's working, but I have a lot of work to do on that still. But right now I'm just focusing on the internal pins, but this will be something that'll be coming in the future. But anyway, each one of these outlets, you'll be able to program individually. So of course you can give it a name. So say this was a return pump, give it a name, and a control pump, we'll say a return pump. And in here you can decide which feed modes, if you want this to turn off, when feed mode A is triggered, you could hit that, or you could leave it off and then it won't be affected by the feed modes. And then you could give it some additional time after the feed mode's over, in seconds, before that'll turn back on. So go ahead and save that. And then say you had, outlet 2, skimmer. I'll set that up as a skimmer. And right now the skimmer and the return pump are very similar. It'll probably change a little bit. But say you want your skimmer to turn on, after the return pump has had a chance to equalize, the water level in the sump. So say you give that an extra 120 seconds before that would turn on. Logging, I don't have this implemented yet, but you'll be able to log, when the outlets turn on and off. Say if you set this one up as your heater, you would select, which one of your probes, and that comes back over to, your temperature probes that are configured here. And then you could set the on, and off temperature on them. Say if you had your fuge light. And say you want this to turn on at 8 o'clock at night, which is what, 20, and then turn off at 8 o'clock in the morning. You go ahead and save that, and basically so on. I think that was all the different types here. And then you have always, and always will either be always on or always off. You can have them there. So I've already got the internal bus program. So I have return pump, which has a 60-second delay after the feed mode. Outlet 2 is the skimmer. 3 is the fuge light. And 4 is my wave maker pump. And this is the configuration of the Raspberry Pi that's hooked up to my 40 breeder system right now. So we can go over and take a look at that in just a few minutes. And I think that's everything within the configurator utility right now. So I'll give that let's close that out. And let me start my server back up. The source code, everything is written. I've written it all in Python 3. Just kind of show you here. This is the source code for the server, which is running right here, which goes out. It reads the configuration file, which we just made, and will basically control the status or the state of all of the outlets, depending on which profile you had assigned to it, and all the values there. It reads all of the probes, like your temperature probes, pH probes, all that stuff, and basically just goes on and on. We'll log the data out to files, raise events, and broadcast out any status changes that are made here. And I will make the source code available when the time's right. It's just not ready yet. I'd rather get some more things working first. So please don't ask. It will come. If you have a specific question, sure, I'd be happy to help you out there, but I can't just give everything over right now because it's not finished yet. So and then this is the source code for the configuration utility, and just different class modules and stuff in here. So we'll get into that probably later. I guess we'll get more into show more of the functionality. And then dashboard. I don't have the alarms or test log. They're not doing anything yet. Graphs is working. So all of the sensor data, when it pops up, we'll log the data out to files. And I can just show you. I'm just doing a simple log file for each one. So for instance, here's this particular temperature probe, and this is the data from yesterday. So I were to open that up, and this is the temperature probe that's hooked up. It just basically logs the date, the time, and then this is the temperature in Celsius, and this is the temperature in Fahrenheit, and it just logs that every 5 minutes throughout the day, and every day it'll roll over to a new log file. And that's basically how each one of these probes is working. For instance, here's pH, and it's very similar, just date, time, and the pH value. So it's a pretty simple system. So it's just constantly logging all of the data, and then in our dashboard over here, our application, we're able to come in and pick which probe that we would like to see. So suppose I want to see the pH probe, and this is showing me the last day's worth of data on the pH probe. I have the option, and I'll be able to configure this. I'm just what I have right now, but if I want to see the last weeks of data, I just click on that. Last month, there it goes, and this is every 5 minutes for the last 30 days. We also have the ability to plot that versus one of the other ones. So if you want to see the pH versus the temperature, we can do that. And you can mix these up however you like, humidity versus temperature, however you want to do it. You have the options here, so that's working out pretty good. And I think that's all we can show right here. Then I can take you over to the actual hardware. All right, a little bit of a change of scenery. I figure I've talked long enough about the software. Let me just show you quickly it in action. So each one of the outlets has 3 states. It could be on, off, or auto. On and off do exactly what you think they'll do. It just flips the switch, on or off on the outlet. So it'll always be on or always off. Auto will run the program which we set in the configurator earlier. So for instance, if I want to turn my skimmer off, and you can see right back there, I've got the 4 relays, hooked up right there, and you can see the 3 lights. If I hit off on the skimmer, one of those lights will turn out or turn off. and the skimmer will shut down. So let's go ahead and do that. And you can see the light went off, skimmer shut off. What happened in the software was the client detected a state change, broadcast a message out through the messaging system. The server picked up on it and performed the action. And then the server responds back with the current state, and it knows that the outlet is now in the off state. If I were to say auto, it basically does the same thing. Sends the command back to the server. The server knows that it's in the auto mode, and the auto mode basically says, hey, this skimmer's supposed to be on, and it's go ahead and turn back on. And all the other outlets, work the exact same. They either run their program or they're on or off. WaveMaker, I could turn that on if I like, off, turn it on, or just have it run the program. Then we get into the feed modes, which we programmed earlier. So feed mode A, we gave that a 1 minute feed mode, which will shut off my WaveMaker, my return pump, and my skimmer. But when they turn back on, I believe the WaveMaker turns on first, then the return pump, and then the skimmer. So let's go ahead and just hit feed mode A. And the software knows that it's in that mode. It's going to give us a countdown right there. All the status changes, are performed there. And all of the equipment has turned off, just like it was supposed to. And it will do, just provide us some feedback, in the background so I know what's going on. And it's telling us how much time is left, in the feed mode. And we'll just, wait a minute, and then things will start to turn back on. And while we're waiting for that, this is kind of, my temporary project board. I do want to put all of this in a more permanent home. And once I figure out, the layout of everything, I'll probably get a 3D printer and print up a nice little enclosure for stuff. But for right now, this is working out just fine. And here we see we're getting to the end of the feed timer. And then, so the feed timer is now over, and the post delay, which we programmed in for some of those other outlets, is now happening. So the WaveMaker didn't have any delay, so that immediately turned on. You can see my WaveMaker's going right now. And now we're just waiting for the return pump and a skimmer to turn on, which, the return pump will come on in another 30 seconds. And then 2 minutes later, the skimmer will come on. But yeah, so it's working out pretty good so far. I'm pretty impressed with what I've been able to accomplish so far. It's working out pretty good, and I really can't wait to get more features included into this, and to turn this into an actual working thing that people can use. And you probably heard the click. The return pump has turned itself on, and it's now needs to empty out the sump, and then the skimmer will turn back on in another 2 minutes. But that's basically how the feed timer works. So what's next? I still have some work to do on this dashboard interface here. I'm going to be redoing how all the probe data is handled. There's some things I want to change about that, so I'll be working on that soon. And right now, this is an application. It's a native application running on the Raspberry Pi. Like I said, everything's written in Python, and I used tkinter or tkinter to write the user interface, which is pretty, bare bones. I'll probably rewrite this as a web application. That way it'll be, I I'll be able to do, I think, more with the user interface, probably easier to maintain it. And it'll give me the benefit of being able to access it through any browser. Right now I have to connect via VNC, which is fine, but I think if I were to connect through a browser, that might actually be better. So I'll have to see about that. And there's the skimmer. Timer just completed. And my skimmer just turned itself back on. And yeah, I think I've probably rambled on long enough about this. I still have a lot I could say about it, but I think probably now's a good time to cut this video off. And if you made it this far, hey, thanks for watching. And if you made it this far, I'm sure you've got some questions or comments. I'd love to read them, so leave them below. And see the best I can do to answer them for you. And like I said, this is a work in progress, so this is just kind of where I'm at now. I do plan to keep going with this and hopefully have more to share soon. And then, hopefully I can explain how some of these modules work more in depth at some point. But I think right now is probably a good place to end it. So thank you guys for watching, and I will catch you in the next one.